Alright guys, your central question for today is how do we apply the sum and difference identities for sine and cosine? Let's go ahead and jump right into a problem that asks you to find find the exact value of cosine of 75 degrees. What you're going to try to do is you're going to try to find two angles that either add or subtract to give me 75. And so what I'm going to have here is I'm just going to say that cosine of 75 is the same thing as cosine of 45 plus 30, which is true. 45 plus 30 is 75 degrees. Well, since I'm doing two angles that add to give that to me, I'm going to use this top formula up here, which says that cosine of your first angle, which in this case would be cosine of 45, times cosine of your second angle, which is 30, minus sine of your first angle, which is 45, times sine of your second angle, which is 30. Now, we know from our special right triangles that 45 degrees is a special situation where both legs equal radical 2 over 2. So cosine of 45 and sine of 45 would both be radical 2 over 2. Now, in a 30, 60, 90 triangle, if you remember, across from the 30 is 1/2. So that would mean that sine of 30 is 1/2, and cosine of 30 would be radical 3 over 2. Then we can multiply these and get radical 6 over 4 minus radical 2 over 4. These have the same denominator, so we can scrunch them together and get radical 6 minus radical 2 all over 4. And that will be my exact answer for that problem. All right, if we look at another one, like cosine of 105, again, try to find two angles that add or subtract to give me 105. Well, I could think of 45 plus 60. 45 plus 60 is 105. Notice that if the last digit is a 5, you're going to have to use 45 as one of your numbers. So using the formula again, which looks like it's going to be the top one, I'd have cosine of 45, cosine of 60, minus sine of 45, sine of 60. And just to repeat myself, in a 45-degree triangle, both legs are radical 2 over 2. So cosine of 45 and sine of 45 would both be radical 2 over 2. Now, sine is opposite, and opposite of 60 degrees is always radical 3 over 2, which means cosine of 60 degrees would be 1/2. Multiply, you get radical 2 over 4, minus, multiply, you get radical 6 over 4. Same denominator, so you can scrunch them together. You get radical 2 minus radical 6 over 4. And that would be the answer for that one. All right, now let's try some sine. So what if I ask you to tell me what sine of 345 degrees is? It's done the same way. Come up with two angles that add or subtract to give me 345. Well, again, I'm going to use 45 since it's a 5 at the end, and then that would be 300 degrees. So then using the formula, notice that this is the top one, so I'm going to use this one up here. It would be sine of 45 cosine of 300 plus cosine of 45 sine of 300. And again, to repeat myself, 45 degrees, both legs are radical 2 over 2. So both sine and cosine of 45 degrees will be radical 2 over 2. Now, the issue, though, is, well, what the heck is 300 degrees? Well, if you remember, 300 degrees is in quadrant 4, and it has a reference angle. So there's 300 degrees, has a reference angle of 60, which means that across from 60 is radical 3 over 2, and this is 1/2, and that's your hypotenuse. Watch out for your sign, so that should be negative. Well, cosine is adjacent, so adjacent of this triangle would be 1/2. Sine is opposite, so opposite of this angle would be negative root 3 over 2. Then clean this up, multiply, you get root 2 over 4. Multiply, you get negative root 6 over 4. You can scrunch them together and get root 2 minus root 6 over 4. And that would be my answer for that one. Another similar problem to this is sine of 15 degrees. Well, this time I don't have a choice. I've got to use the subtraction. So I'm going to say that 15 degrees would be 45 minus 30, which is true. And so using that formula, I would have sine of 45 cosine of 30 minus cosine of 45 sine of 30. And then again, in a 45 degree triangle, the legs are root 2 over 2, so both sine and cosine of 45 degrees would be root 2 over 2. Cosine is adjacent to 30, and then sine is opposite. Opposite of 30 is 1/2, so adjacent to 30 would be root 3 over 2. Multiply, you get root 6 over 4, minus multiply, you get root 2 over 4. Same denominator, so scrunch them together, you get root 6 minus root 2 over 4, and that will be my answer for that. If you notice with those four problems, you're probably thinking, oh, well, they're always going to be the same numbers. Well, that's not true. For example, I might give you a problem that looks like this. It says, find cosine of x minus y. If I tell you that cosine of x is 3 over 7, and my angle x is between 0 and 90, that means that x is between 0 and 90 degrees, which means I'm in quadrant 1. So let me draw a triangle to represent this right quick. So if I drew a triangle, triangle x, cosine's adjacent, so 3 over hypotenuse would be 7. If you did Pythagorean theorem, you get 49 minus 9, so you get the square root of 40, which technically does simplify, right? 4 times 10 is 40, so that gives me 2 radical 10. All right, so that means even though cosine of x is 3 over 7, with this same triangle, sine of x would be opposite, so that would be 2 root 10 over 7. So that would be sine. So this would be cosine of x, and this will be sine of x. Now, those aren't my answers, but I'm going to use that to get my answer in a minute. Now, over here, it tells me that cosine of y is 1/5. Well, again, y is between 0 and pi over 2, which means y is between 0 and 90 degrees, which means you're in quadrant 1. So let me just draw a triangle to represent this y situation. Cosine is adjacent over hypotenuse. And again, if you do Pythagorean theorem, you get square root of 24, which does simplify 4 times 6, so you get 2 radical 6. And so even though cosine of y is 1 over 5 from the same triangle, sine of y would be 2 radical 6 over 5. And again, those aren't my answers, but I will use them now to get my answer. So using my formula, cosine of x minus y, that is equal to cosine of x times cosine of y plus sine of x times sine of y. And so now let's just plug in what my values are in red and blue. So cosine of x would be 3 over 7. Cosine of y would be 1/5. Sine of x would be 2 radical 10 over 7. And sine of y would be 2 radical 6 over 5. Multiply these together, I would get 3 over 35 plus 2 times 2 is 4. 10 times 6 is 60 over 35. They do have the same denominator, so you can scrunch them together and get 3 plus 4 radical 60 over 35. And then even though you can simplify radical 60, I'm not going to do that right now, but you could if you wanted to simplify radical 60. All right, and then with these trig identities, you can actually, with these new trig identities, you can actually work out some more verifying problems. Like, for example, if I wanted you to verify cosine of 180 plus x, what I would do is I'd use my sum and difference identity for cosine, which would be cosine, let me write it again, cosine of 180 cosine of x minus sine of 180 sine of x, not y, x. And you'd want to prove that that's equal to negative cosine of x. Well, cosine of 180, if you remember, is on the line, and that is negative 1. Sine of 180 is also on the line, and that's equal to 0. And so negative 1 times cosine is negative cosine of x. Negative 0 times sine is just 0. And then negative cosine x plus 0 is just negative cosine of x, which is what I wanted to prove to begin with. So that works out good. A similar one to that is if I wanted you to tell me, verify this. So again, I'd use the sum for identity for sine. So I'd get sine of 270 cosine of A plus cosine of 270 sine of A. Again, sine of 270 is on the line, and sine at 270 is negative 1. Cosine of 270 is on the line, cosine of 270 is 0. And again, just multiply negative 1 times cosine of A will be negative cosine of A, 0 times sine of A will be 0, and then negative cosine of A plus 0 would be negative cosine of A, which is what I wanted to begin with. And that's it for today's lesson.